So recording anyway, so if you drop in and out, if your signal goes out, whatever, don't worry too much. Hopefully mine doesn't. Okay, so hopefully everyone here was here last week. If not, nice to meet you. If not, the video should be available to you guys. Okay, so I had a wee struggle getting up onto Moodle. So it looks likely I'll probably put it on a wee link in Moodle and then have it on YouTube. It's just a wee bit simpler. So for the life of me, it's just a bit of a pain. Okay, but the video is there. Okay, so plan tonight, guys. We'll have a wee quick look at what we did last week. Okay, so I know last week we ended up spending a whole week on what we did the week before that. So I don't want to do that again. So I'll just glance over the wee bit more of the complex brackets, breaking them up. And I'll touch again, I introduced the rules of Indus, and I think that will be important for tonight as well. So if that you don't recognise that, don't worry, I'll explain that in a wee bit. Okay, and then we'll move on to factorisation. So one of the most important aspects of sort of math course. Okay, so we'll spend this full night on it. Okay, so we'll work through it. We'll start from sort of first concepts. I asked you to look, if you had the opportunity through the week, to look back at National 4 just to familiarise yourself and get comfortable with the terms like highest common factor, factorising some simple brackets. Okay, we're going to spend a wee 5, 10, hopefully 20 minutes on that part of it anyway. Okay, so just a wee refresher. If you've got any questions, please shout out. Okay, and we'll go through them as they come up. Okay, so don't sit in a question. Don't think it's a silly question. We're all in the same boat here. Okay, we're all in the same place. So just please throw it out. Okay. So factorisation, we'll go through highest common factor, thing called difference of two squares, and then we'll look at something called trinomials. Okay, essentially what we're doing is taking some of those algebraic equations that we've been working on the last couple of weeks, okay, and doing the reverse and putting them back into brackets. Okay, and that's a really good skill to have if you're ever going to look at data and analysing data. And graph data and things like that. Okay, it's a good skill to be able to just tidy some stuff up, and you can take a lot from that. Okay, so it might not be apparent right now, but we'll cover it again in the course when we're graphing out things like trinomials and we're drawing graphs, taking gradients and taking max and min points and things like that. Okay, then some of these things will click home. Okay, so why they do this, I'm not too sure. Do one part at the start and one part a wee bit later on. Okay, it's up for anyone's guess, but that is what it is. Okay, so I'm just going to start quickly. Remember that I'm sharing my screen, so if I put anything up in front of it and you think when I'm looking down I'm writing away, okay, it happened a couple of times last week, so just give me a wee excuse me, I can't see your screen comment, and I will correct that as soon as possible. Okay. Oh, got my jumper. Okay, so want to just pick on something called rules of Indus. Okay, and I touched on it last week, and essentially it's what we do with how we manage the rules of working with powers. So when we're squaring something, or when it's to the power 3 or 4, okay, it's how we manage that if we're multiplying it. Okay, and that happened a lot when we were breaking up sort of the brackets. Okay, so if we've got something like x squared, and that's timesing by another x squared symbol plus say 2x, okay, just looking at the rules and thinking what those rules are. Okay, so we said this formula here, a, okay, and a is just a constant in this case, to the power of m. Okay.
Sorry, Daniel, I can't see the screen.
See, it happens straight away. Thank you for that.
No worries.
I don't know why I did that. There we go. All right.
Cheers, thank you.
You'd think after 19 months I'd be used to it. Okay, so maybe next week it'll be flawless. Let's start that again, just so we're all on the same page. Okay, it's how we deal with powers. Okay, so something to the power of 2, 3, whatever it may be. Okay, so if you are looking at, say, we're breaking up the bracket x squared plus, I don't know, 3x there. Okay, what are we doing when we multiply out these symbols? Okay, so the rule is e to the power n, okay, equals a to the m plus n. So that when you're multiplying out two numbers to the power of, okay, we are adding on the powers. So putting that, writing that out into the x squared times x squared. Okay, so we'll write that out. It's not the tidiest, but that's 3x there. Okay, all that becomes x squared times x squared, and then plus x squared times 3x. Okay, and I'm going to put a wee 1 there. Okay, because remember, if an x is there, it's x to the power of 1. If there's no power there, that's what it is. Okay, so x to the power of 1. So that would just be x, that multiplied sign in between, is just adding those powers, adding those indices. Okay, and that'd be x squared plus 1 as well. Okay, so the numbers in front of it. Okay, so work out, let's put a number there. Put that number multiplied by that number, followed by the x, followed by the indus plus the indus. Okay, if I'm losing anyone, just let me know. Likewise, that x squared and x squared, we've not written it, but that's 1x squared, 1x squared. Okay, so those ones would multiply. 1 times 1 is 1. And those 2's are added together. Okay, so your final equation is like that. Okay, so when we're multiplying x squared and x squared, or x squared and x cubed, or x to the 3 to the power of 3 times x to the power of 4, those indices, the small numbers that are floating, add together. Okay, so I think we were quite comfortable with that last week, but there is a rule there, and just familiarise yourself with that, so we're good with it. Okay. In the notes pack, in the dynamic notes pack, the one that I tend to use, okay, that's the way they write it out, where A is just a constant in this case, M's one of the powers, N's the other, and then that's your rule. Okay. So that's indices. Because we're looking at indices so much, I thought I'd just run through that first. Okay. Left you last week with a couple of tutorials to do. Okay, we were just breaking up brackets. Okay, so it was question 7, question 9, I think 10, 11, 12. Okay, and I think I never said do 13. I think 13, some quite difficult ones. Okay, if anyone had a go at them. But certainly 7, 9, 10, 11 and 12 we sort of covered last week. Did anyone try them, and did anyone have any issues with them? Okay. We'll go over a couple. Okay. If you want me to go over anything specific, give me a shout out. Okay, so I'll spend the next 5-10 minutes just going over one of question 9, one of question 10, one of question 11, one of question 12. All right. If anyone wants to go on any specific question, if some of it doesn't match up at the back, then let me know. Just letting someone else in 2 seconds. Hi, Emma. Okay, so questions from last week. Asked you to go over question 9. Okay, so I will pack E. Okay, E was minus 5 x squared minus 8x plus 2. Okay, and we're just asked to break up that bracket, so no problem at all. Minus 5x squared. Okay, this bit, watch the symbol. Two negatives become a positive. Okay, just be careful with that. So that'd be plus 40x.
Sorry, Daniel, I'm being a pain again. Mine's is froze. I don't know what's happened with it.
Very good question. Gotta love technology, don't you?
Nothing happening on my screen either.
No, none's happening.
That's what happens with Michael.
Don't know, I think I hung up on me. Okay. Is that up now?
Yeah.
Perfect. Perfect. Okay, so I'll go, you know what, I'll just start again. Don't know why I'm loading the equation out. Thank you again. I don't know why that happened. Blame my Wi-Fi. Okay, so the question I picked was 9e, okay, and it was just because there was a wee negative in it, and that sometimes throws people. Right, so plus 2. Okay, so just breaking that bracket, we're just going through multiplying every single part of that expression. Okay, so minus 5 times x squared times 8 times 2. Okay, so minus 5 x squared. Be careful with the symbol, so the negative and the negative. Okay, so two negatives make a positive. Positive 40x. Negative times a positive this time. Okay, it becomes a negative 10. Okay, so nice and underlined there. Question 10 in the tutorials. Okay, I picked K. Okay, so question 10 threw in a bracket at the front and a sort of trinomial. Okay, 3 expressions second. Okay, now the process we use is just the same, so don't worry about it. Okay, we're taking that first term and we're just working through methodically, so we're just doing first term in the second bracket, second term in the second bracket, third term. Okay, we're going to that second part of the expression in the bracket, and we're just doing multiplying there, and multiplying there. Okay, so we're just taking both expressions in the bracket, multiplying the other bracket all the way through. Okay, so just working through that. X times x squared, so that's our rules of Indus, so that becomes x cubed. X times negative 5x, okay, negative 5x squared. X times plus 5, okay, that stays positive 5x. Okay, so plus 3x squared minus 15x plus 15. Now it's just a case of tidying that up. Okay, so your x cubed is only x cubed there, so we don't touch that. This minus 5x, we look for any, oh, what would that become? That's minus 5x squared, sorry guys. Okay, minus 5x squared. So that minus 5x squared, we're looking for another x squared term. okay, we've got positive 3x there. Okay, so negative 5x squared plus positive 3x, oops, that's minus 2x squared. Okay, next up, we've got positive 5x and we've got negative 15x. Okay, so we're left with negative 10x, and we've only got one term at the end, and that's a plus 15. Okay, so that's that tidied up. Okay. 11, what are we throwing in question 11? Question 11, I picked n. Okay, and this just throws in, it's got two brackets again, but it throws in a negative sign. Okay, and this is just a case of being careful as we go through. Same process, we're taking the x, multiplying through, we're taking the negative 10 and multiplying that through as well. So it's the exact same process. Okay. X cubed minus 3x squared minus 8x minus 10x squared. That's a wee squared, sorry. Plus 30x, so watch that symbols. Okay, minus 10 times minus 8 is plus 80. Collecting those terms together, x cubed minus 3x minus 10x is minus 13x squared. Okay, so again, it's the same process, just be careful with those symbols. Okay, so all those negatives, we're creating positives out of them. Okay. And the last one I'll do, guys, from question 12. Okay. We'll do question I. Okay, and the difference here is there's just a term in front of that x. Okay. Just to lead that a wee bit more confusing. Okay, so they put a couple of terms in front of the x. Okay, so just as we were doing with that rules of Indus, okay, this 5x, we're going to take, we're going to multiply here, we're going to multiply here, we're going to multiply here. Okay, so we're going to take 5x times 2x squared. So we're going to take 5 and multiply by the 2. So the two numbers on the left hand side, these get multiplied together. Okay, so that becomes 10x, and then the indices we add together. Okay, so remember the floating number, when we're multiplying the 2x terms, okay, that floating number just gets added together. Okay, so that 1 there gets added to that 2, it becomes cubed. Okay, does that make sense? Okay, so just doing the next one, 15, that's x to the 1, 3x to the 1, so that's 15x squared. And then minus, okay, because you've got that wee minus there. Okay, 5 times 7, 35, and then that x is there. Okay, then just use minus 2's. So the minus 2 times that, times that, times that. Okay, just be careful with the symbols. So minus 2 times minus 2 times 2x squared. Okay, so the 2 and 2 multiply together, we've got 4x squared. Okay, minus 2 times plus 3x minus 6x. Then the minus 2 times minus 7 becomes plus 14. Okay, happy with that? 10x cubed, tidying that up, 15x squared minus 4x squared plus 11x squared. minus 35x minus 6x. Okay, so both negative, so be careful which direction you're going. Okay, so minus 35, and we're taking away another 6, so we're ending up with minus 41x. Okay, and we're left with plus 14. There's no other single numbers. Okay, so that's really as complicated as we push the breaking up brackets. Okay. When we're looking at factorising, so we're taking that next step, okay, and we're effectively doing that in reverse. When we're looking at factorising, we'll never do an x cubed term. Okay, so we won't be looking at x cubed terms, so that's quite good. Okay, we'll only be looking at sort of x squared, sort of trinomials. Okay, so trinomials are just 3 terms. Okay, so we'll never go up to x cubed. But that could come up, breaking up that type of bracket and just tidying that up. Okay, so just be aware of that. Just practice. So that was question 12 in the handout. Okay, note back. Okay, perfect. Let's go for it. Factorising. Okay, what is a factor? Okay, in math, a factor of another number, the number that divides without any remainder. Okay, so factor of 4 would be 2, because 2 goes into 4 without any remainder. We're not left with anything left over. Okay, so let's write that out. If we're looking for factors of 4, okay, we can say 1 times 4, okay, so the number 1 and the number 4 are factors. And we can also do 2 times 2. So your factors, when we write them out, would be 1, 2, and 4. 3 wouldn't be a factor because it doesn't multiply, and you can't multiply that into 4 without having a remainder. Okay, so nothing multiplies by 3 to give you the number 4 unless you start using decimals and things, okay? That's why that's not. So factors of 4, 1, 2, and 4. Okay, go up a wee bit. 12 would be 1 times 12. Okay, what else multiplies to make 12? And 2 times 6, and you can do 3 times 4. Okay, so again, you've got 1, 2, 3, 4 are all factors. 6 is a factor, and 12 is a factor. Okay, 5 won't be a factor because it doesn't multiply in without being left with any remainder. Likewise, 7, 8, 9, 10, okay, and 11. So that's your factors there. Just one more very quickly. 18, 1 times 18. 1, you'll see, is always going to be a factor. 1 in the number itself. We always state that as a factor. 2 times 9, okay, even numbers, 2 will always be a factor. And 3 times 6. 4 isn't, 5 isn't, okay, 7, 8 aren't either. Okay, so it just goes to 9. So 1, 2, 3, 6, 9, and 18. Okay, that's probably before Nat 4, but you'll certainly look at that in Nat 4. But we're going to throw in, oh, someone in the room. We want to throw in letters. Okay, so algebraic functions. So how do we take factors of that? Okay, and it's the same process, guys, so don't be fearful of it. So we were looking for factors of 4x. Okay, we could do 1 again, okay, times 4x. We could do 2 times 2x. And we can do 4 times x. Okay, missing any. So factors in that case would be 1, 2, 4, x, 2x, 4x. Okay. 6x squared. Now we're getting a wee bit more complicated, so we're going to build up the amount of factors that we've got. Okay. Okay, so 6x squared, 1 times 6x squared, 2 times 3x squared, 6 times x squared. Okay, so that makes sense. But what about if we had terms or expressions with just x in them? Could we multiply 1x by something to make 6x squared? Okay, so that would be a factor as well. So we could do x multiplied by 6x, and that would give us 6x squared as well. Okay, so x would be a factor. Okay, we could also do 2x. We could multiply that by 3x, and we'd get 6x squared as well. Okay, the last thing on. So that means 2x and 3x as well. Okay. Other than that, we've got no other factors. Okay, so you could say 3x as well, multiply by 2x. We've already got that. That's just writing that in a different way. Okay, so you don't need to do both. Okay, so we've got slightly more complicated. Okay, but we've built up a lot more factors there. Okay, so if we were writing that out, 1, 2, 3, 6, x, 2x, 3x. Don't worry, you'll never be asked to write all this out. 6x. Okay, and then we've got our 6x squared, 3x squared. Don't know why I did those ones backwards. Okay, it works out. Okay, so that's all your factors for 6x squared. Okay, so that's factors. Okay, so is everyone sort of comfortable with that? I think that's still level 4. Okay, until we get up to sort of double brackets, we're probably not in level 5 yet. Okay, so really just practicing our skills. Okay, so if everyone's comfortable, if everyone sees where I'm going with that, that's fine. Okay, so the next thing I want to do is something called highest common factor. Okay, so this is important when we've got two different numbers. Okay, so when we start building this up, there's going to be 2 and 3 terms in the expressions that we're going to do. Okay, so that's where we're going with this. So if I've got 2 numbers, I want to look for the highest common factor. Okay, what factor have they got in common? Okay, and what's the highest one? All right, closing the name. Okay, so looking for the factor that they've got in common. So if I start with 2 numbers we've done already, 12 and 18, and I write out all the factors that we took for 12, and 1, 2, 3, 4, 6, and 12. Okay, and I'd go through all the factors that we've got for 18, 1, 2, 3, not 4. Okay, we've got 6, 9, and 18. So what factor have they got in common? All right, so 1 we've got in common, 2 in common, 3 in common. We're continuing going up. Are we at the highest yet? Okay, so we'll continue along that line. 4 they've not got in common. 5 isn't a factor for either of them. 6 they've got in common. Okay. 8, nope. Oh, sorry. 7, 8, nope, aren't factors. 9 isn't a factor for 12. Okay. 12 isn't a factor for 18, and 18 is obviously not a factor for 12. So the highest common factor, the highest factor they've got, okay, in common with each other would be 6. Okay, now this is important when we start breaking up terms. Okay, that we're able to extract the highest common one. Okay, because sometimes you'll look at a number and they'll both be an even number. Okay, so obviously a common factor would be 2, but very often it won't be the highest one. So we want the absolute highest common factor. So it's been good with your times tables. All right, so just be really familiar with it. And that sounds daft, but just make sure you're comfortable with them. Okay, so all your 6 and 7 and 8 and 9 times tables, just familiarise yourself with them. Very rarely will they go into 11 and 12 times table, but they do no harm if you sort of just have a wee read over them, just familiarise yourself with them. 11 and 12 times tables probably better for you for when you're doing square numbers. Okay, so 11 squared 121, being able to recognise that would be quite good. Okay, 12 squared 144, being able to recognise that would be quite good. Okay, so just familiarise yourself with that and just make sure you can spot very quickly. Okay, because remember, when it comes to the exam, under pressure, you'll be working to a time. Okay, you want to spot it like that. Okay, silly mistakes are just that, they're just silly mistakes that you wouldn't do in any normal day. Okay, so highest common factor of 12 and 18, we've decided is 6. Let's throw in a letter. Okay, or a couple of letters in this case. 4x. Okay, so the number we just looked at. And let's look at the number 6x squared. Okay, so where do we start with that? So we've worked out the factors for both of these just previously, so just up the page. Okay, so for argument's sake, let's just look at what they were. 1, 2, 4x. And x squared was quite extensive, wasn't it? So 1, 2, 3, 6 x. So don't want to get this too messy. X squared. And 6x squared. Okay, so hopefully you can see that okay. Okay, 6x squared is quite a lot. Okay, so when we're talking about common factors, factors they've got in common, let's just go through them. 1, always the case, 1's always going to be a factor, so if that's the highest common factor, you can't really simplify any further. 2 they've got, okay, so that's got the potential. 3, no. 4, no. 5, no. 6, no. Okay, so 1 and 2 so far. Okay, but then we start going into letters. So they've actually got a couple of these numbers and letters in common as well. So they've both got x as a factor, and they've both got 2x as a factor. Okay, the rest we can sort of rule out. Okay, so they've got 4 common factors. Okay, so the highest one is going to be the x term with the highest power. Okay, so that's quite important. So the highest common factor will be the x term. I'll put that like that. Okay, with the highest factor. Okay, so what I mean by that is there's no x term in front of these single numbers. Okay, but there is an x term in front of this. So 2 is a common factor and 2x is a common factor. So the highest one would be the 2x term. Okay. Now it's not, but if there was a 2x squared and 2x squared as common factors, and 2x was a common factor, then 2x squared would be the highest. Okay, so the x term with the highest power becomes the highest common factor. Okay, so you're looking at both the number in front of it, but also the power. Okay, so okay, so we all comfortable with that? So now we get on to start factorising brackets, okay, and start looking at algebraic expressions and start pulling out things like common factors. So we start recognising things in these algebraic expressions. Okay, so when I'm talking about algebraic expressions, we've been working with them the last couple of weeks. Okay, so if we look at, red, if we look at the term 3x plus 12. Okay, so we're familiar with that sort of setup. Okay, so previously we worked with a bracket and we broke out the bracket. So we broke out a bracket 3x plus 4, and that would equal 3x plus 12. Okay, so we've been working in that direction with algebraic expressions. What factorising allows us to do is take that expression and go backwards and put it into the bracket. Okay, so how do we go about doing that? We look for a common factor. Okay, so the first thing we do with any of these expressions, the first first rule, I suppose, first action we do is look for the common factor, and we simplify that expression as much as possible. Okay, so if we've just been given 3x plus 12, and the question is factorise, so factorise 3x plus 12. Don't know why I wrote it like that. What we're looking for is the highest common factor between this number and this number. Okay, so we take that out and then we put the rest in a bracket, and that tidies it up. So the highest common factor, the highest multiple, the highest times table, okay, that's the word I'm looking for. The highest times table that both those numbers are on is the 3 times table. Okay, 3 times 1, 3 times 4. Okay, worrying I had to think about that. So 3 times 1 and 3 times 4, so they're both in the 3 times table. So a common factor, the highest common factor they've got in common is the number 3. Okay, and what do we multiply to get 3x? We multiply that by x. What do we multiply to get 12? We multiply that by 4. Okay, so that's that expression factorised. Okay, so we look for the common factors, and that, believe it or not, is a simplified form. Okay, so let's continue with that, and we'll look at another one. We'll pull some out. Okay, so if we do the example 5x minus 25. Okay, what is the common factor there? Okay, so the highest times table that both that number 5 and the number 25 is on is the 5 times table. Okay, in this case it's just the lowest number. So we're taking that out as a common factor. Tidying that up, it would just be 5, and then in the bracket it would be what you multiply by, so 5x minus 5. Okay, that's that term factorised. Okay, so a wee bit more complicated. We'll throw in, okay, factorise the term 12x plus 18. Okay, so again, we're looking for the highest common factor. Okay, so we're looking for the common factor here. We're looking for the highest time table that they're both on. Okay, now what we've done previously is just taking that number in front of the x, and it happens to be that's the highest common factor. In this case, you can't multiply 12 into 18, so that's not the case here. So we need to work through them and just work through them methodically. They're both going to be in the 1 times table. Okay, so 1's a common factor. They're both even, so 2's a common factor. Okay, 3, so 3 times 4 makes 12, and 3 times 6 makes 18. So that says 4's not, 5's not, but 6 goes into 12, and 6 goes into 18 3 times. Okay, so 6 is a common factor. 7's not, 8's not, 9's not, 10's not, 11's not, 12's not. Okay. Highest common factor in that case is going to be this 6. That's the term we put in the outside of the bracket. Okay, so that's the number that we'll put in the outside of the bracket. 6, bracket, what makes 12x? 2x plus 3. Okay, so we're simplifying that 12x plus 18 by removing a common factor, putting that to one side, and then bracketing the rest. Okay. Now, important feature or important part of it is sometimes they will put the number and letter at different points. They'll switch it about like this. Okay, 16 minus 40 f. Okay, and they'll ask you to factorize that. Okay, so run that one up there. So they'll ask you to factorize that, and it's the same process. The only reason they've done that is because that f value is a negative and it looks a wee bit neater. So the equation just looks a wee bit neater. So there's nothing in algebra to say you can't set that equation up like that. Okay, so don't be worried if the letter, okay, and remember that letter is just a variable. So previously we've been working with x's, but you can work with f's, k's, v's, whatever it is. Same thing, it's just a variable, so don't worry about that letter. The reason they've put it second is just because it's a negative and it looks neater. That's it. Okay, so there's no specific rule dictating you do that. It just looks a wee bit neater. So the same process, if you were asked to factorize that, or you've seen that and you wanted to simplify it, the same thing apply. You would go through all the common factors. 1, 2, 3 isn't, 4 is, 5 isn't, 6 isn't, 7 isn't, 8 is. Okay, then you can go through the rest. Okay, so 1, 2, 4, and 8. Highest common factor here is going to be this number 8. Okay, so 9 isn't, 10 isn't, 11 isn't, and the rest of the way up. Okay, so 16, same thing applies, sorry. 8 goes on the outside of the bracket, 16 goes to 2, okay, 8 times 2. That's going to be a negative, so 8 times what equals 40. Okay, so don't be put off if they switch a letter up. They try and, I'm not trying to trick you, it's just a wee bit neater to look at. Okay. Let's throw in a wee squared number. Okay, so look at that. So p squared plus 5p. Okay, so as I said, we could have common factors as well that are letters. Okay, so in both of those terms, there's a letter p. Okay, one's got p squared, so effectively that's just p times p. Okay, and one's 5p, there's 5 lots of p's. Okay, again, don't worry too much the fact it's the letter p. In algebra, you can use any letter and it's just a variable. Okay, so p is going to be our common factor in this case. There's no other common factors other than the number 1. Okay, so p is the common factor. So if they ask you to factorize an equation like that, you would take p out, in your bracket would be 5, oh sorry, p plus 5. Okay. The thing is, you can check this very quickly as well, because we've been breaking brackets the last couple of weeks. You can check that very quickly just by multiplying it out. So p times p times 5. Okay, so a nice simple one, p squared plus 5p. Okay, is that what that equals? Yeah.
See if you pick the wrong like common factors. So say you get one that's like lower. So like the one you did before that was 8. I picked 4 because I tried to do them like with
Okay.
you.
Brilliant.
I picked 4, so technically my answer isn't wrong, but because it's not the highest, would I lose the mark for that?
So let's work through it and let's look at it. Okay, so if you picked the number 4 there, which is easily done, so you're absolutely right. 4 goes into both of them, so that is a common factor. So let's write that equation out. If you pick the number 4, okay, you would have 4 on the outside, you would have 4 there, and you'd be minus 10f. Now what you would see is this term can be simplified further. Okay, so if you look at that, and it's quite a good one to look at, is you've got the number 4 and the number 10. There's a common factor to both of them as well.
Right, okay.
Okay, so if you've seen that and you went, right, 4 and 10, you can actually, there's a common factor of 2 there. Okay, so you can actually simplify that more. So what that equation could become, if you simplified that down, would be 4 times 2. You can bring 2 out of that bracket, and that would become 2 minus 5f. Okay, all this is, that would just become 8.
Okay, so say if you'd done that, say in an exam, and then you wrote out exactly what you've just written out, would you still get the marks, but you've just done it with extra steps?
Yes.
Cool.
Because you've recognised your mistake and you've sort of corrected it as well. So you've actually taken an extra step, as you say. But we'll actually look at where that becomes important later on. So it's a good one to pick up on. But it's absolutely the case that some numbers you just won't recognise that highest common one. But that's the sort of corrective action you need to take. Look at that answer. Don't be happy with it straight away. Say, can I simplify 4 and 10? The answer is yes. Okay. Likewise, I would look at, is there any common factor in 2 and 5? Very quickly, you could say no. Okay, other than the number 1. Okay, 2 doesn't go into it, 3 doesn't go into it, 4 and 5 doesn't go into it. Okay, so
That's great, thank you.
excellent point. Okay, so we check there. Perfect. Okay. We'll do that one. So we'll have a wee look. We'll throw in a number and a letter. Okay, so let's look for 8h squared, 16h. Okay. What are the factors there? Okay, so we've got numbers in front of us, and it's pretty clear you can see the number 8 is going to be the highest common factor, but they also share a letter. Okay, so we can take out, so when we went through a couple back, okay, and we went through 6x squared and we went through 4x and we took out common factors there. Okay, we took the number and the letter. And the highest common factor was the highest powered letter, remember? Okay, so the same applies here. So we can take 8 out as a common factor. Okay, but we can also take h. So 8h times what is 8h squared? We throw in an h there. Plus 16h, so 8h times what is 16h? That's a 2. Okay, so raising the complexity a wee bit more. Okay, so remember we can take letters and numbers. Okay, so if there's a big number on the left hand side, oh, someone in the waiting room. Okay, and a letter there, we're going to take the letter with the highest power as the highest common factor. Okay, so next one there, let's do one more. A couple more actually, don't know why there's a red line. Okay, let's do this one, which is 8x minus 12x squared. Okay, so we're asked to factorise that. Remember I've said they can put the terms in any order they want, okay, as long as it looks neat. So that 8x normally would have x squared first, then 8x, then the numerical value on its own, and it'd be nice and ordered. Because that's negative 12x squared, it looks neater if they do that. Okay, so it just looks a bit out of order, but there's nothing algebraically wrong with it. Okay, so same thing applies. So we're still looking for common factors, and then we'll look and work out the bracket later on. Okay, so the common factor here, just go through them. 1, yes. 2, yes. 3, no. Okay, 3 goes into 12, but it doesn't go into 8. Okay, 1 yes, 2 yes, 3 no, 4 yes, 5 no, 6 no, 7 no, 8 no. Okay, so highest common factor I've taken is 4. Okay, both of them share a letter, x and x. Okay, so we can take that out as a common term. Okay, so that becomes 4x. What times 4x makes 8x is 2, minus what times 4x makes minus x squared. Well, sorry, minus 12x squared, and it's 3x. Okay. Again, if you want to double check, if you get towards the end of it, okay, so obviously we're going to move into some more complex ones we might have to do a couple of times, okay. If you just want to double check at the end, that's absolutely fine. If you write another line, just put a wee star beside it saying double check or something along those lines. You won't lose any marks or anything, okay. Just keep it neat. 4x, double checking I'm doing it wrong. 4x times 2, 8x, breaking that bracket, 4x times negative 3x, negative 12x squared. Okay, so I'm happy with that. If you were to double check in the exam or in an assessment, make sure it's clear what your final answer is. Okay, and then put like a wee star or something beside it, just saying check. Okay, you wouldn't lose any marks. It's really obvious what your final answer is, but make it really obvious. All right. Some people. Right. So happy with that one. Let's throw in. For a squared b plus 16ab squared. Just to be really annoying. Okay, factorise that. What have they all got in common? Focus on each part of the expression. So 24 and 16 first. What have they got in common? Okay, you can just go through all the numbers, but number 8 goes into 16, number 8 goes into 24, 9 doesn't, 10 doesn't, 11 doesn't, 12 doesn't. Okay, and that's going to be your highest. So 8 goes into both of them. So I'm going to remove 8. They've also both got the letter A, and they've also both got the letter B. Okay. A only turns up once over here, so that's your highest. B only turns up once here, so that's your highest. Okay. You probably won't see anything like this, but it's better to be aware of it than not. Okay. Just don't worry with the letters. I'm not trying to scare you with the letters, just be comfortable with them. Okay, so AAB, taking that out, what times that? It's going to be 3A. Okay, so 3A times AAB is going to be 24, A squared, B, plus 2, B. Okay, so it's slightly harder. Be very surprised to see something in that format. Okay, but be aware something like that might turn up. Okay, so that's 7 o'clock. So just one more just to look at the powers, just so we're comfortable with the powers and different indices. Okay, so again, I'll move that out of the way so we don't get confused by it. I have 14x cubed plus 21x squared. Okay. What we can do is actually take the common factor for both these numbers. Okay. They're both the highest times table they're both in is going to be the 7 times table. Okay. So your first one, 7. Okay. Then you've got two x terms. So you know x is going to be in both of them. Okay. But you've actually got x squared and you've got an x cubed. Okay, so you can actually take x squared out of both of them. So you can remove an x squared from both of them and it will still work. So if I put 7x squared, okay, that means that would become 2x. 7x squared times 2x would become 14x cubed. Okay, so remember that rule of Indus, that's 2 plus 1 effectively. Okay, but that one is just not written. And then that would be 3. Okay, so 7x squared times 3 would be 21x squared. Okay, so that would be the simplest bracket there. Okay, again, these two I've just done. That one, that one. You might see this in the non-calculator, something like this, factorise it. Okay, something like this would be a stretch, but it could. Okay, so just be familiar with them and just be comfortable with that. All right, so that's me been talking for an hour, guys, and I've thrown quite a lot at you. A lot of it should be revision from Nat 4, okay, but if it's not, just look over, digest it. How about we take, say, 15 minutes, guys, okay, so take 5 minutes yourself, get a bit of fresh air, we walk. Okay, on page 25 of that booklet, okay, so where I'm taking all the examples from, all your tutorial questions from that booklet I showed last week. I've stupidly not got it open. Okay, if we go to page 25 and 26, okay, does everyone know what I'm talking about? The booklet, the tutorial questions in it. If we go to page 25 and 26, questions 1 to 7, okay, that's quite a big jump. Okay, so don't do them all, just pick a few questions and try them out. Okay, so different levels. So question 1 would obviously be simpler, more basic ones. Okay, try for 5-10 minutes. Okay, try some of them towards question 5, 6, 7. Okay, just familiarize yourself. If you don't get it, if you look at it, you just can't see it. Okay, ask me and go over 1 or 2 and then we'll move on. Okay, guys, so let's take it until 20 past. Okay, so go get a wee bit of fresh air, let the dog out, what we need to do, and we'll come back together at 20 past. Okay.
Sorry, can I just double check what question that was?
So I've got written down here questions 1 to 7, but I've not got the booklet open. If anyone's got the booklet, so obviously don't do every question, so that will probably be 1 to 8 or whatever. Maybe take 1 or 2 from each number. Okay. It seems like a big jump. I'll just look at the booklet now. Just to make sure that makes sense what I've written down there. Have you got the booklet in front of you? Is that... Sorry, guys. Well, middle. Is everyone getting into middle okay? Just to double check. Yeah, we're all good. If not, give me a shout. Right, share. Has everyone seen middle on my screen? Yeah. Okay, so middle, we've got these Nat 5 packs. Okay, Nat 5 pack 1, Nat 5 pack 2. Okay. That Nat 5 pack 1 is what we're working on right now, so unit EF. That's expressions and formula. Okay, so unit Nat 5 pack 1, when I'm telling you if we take some time and do some questions, that's where it's coming from, okay, these packs. So if I open that up, 20, 25 and 26, eating into break here. If you know what you're looking at, head off and come back at 22. We'll just put this up just so we're okay. Have it on the screen.
I've been able to get into the packs before, but now it's showing me that it's saying that I'm not part of any classes.
Oh, that's not a good sign. Right, can you see that on my screen?
Yeah.
Right. Send me a wee note on that. Was that Brooke?
Yeah.
Send me a wee note on that, and I'll, not tonight probably, so the juice. But I'll take a wee look at that and just make sure for whatever reason that is.
It's saying Cumbernauld evening class, and then it's the 2 homework assignments, and then it was saying about somebody called Amanda's class, and it's saying I don't have access to that obviously, but I'm not getting anything else.
Are you definitely on the right one? Because on Moodle we've got 2 different like modules. One of them is the homework one, and one of them is for the actual class.
So
Would you believe it? I'm on the wrong one. It's fine.
that.
Thank you so much. I actually cannot believe I just did that. I think my brain's just fizzled out working. Thank you.
No worries.
Stuff. Okay, so perfect. I'll put it on the screen, guys. So what did I say? 25 and 26. So yeah, finding common factor. Should be able to blitz a couple of them out, guys. And then 6 and 7 gets a wee bit harder. Okay. So maybe just try a couple of these. Okay. Yeah. I'll leave that up on the screen. Okay, guys, so 20 past. See you soon. Oh, stop the share. Okay, so there's no questions. I'll just move on. Okay, so the next part, we're going to combine both of them. Okay, we're going to combine the common factor and then difference of 2 squares. Okay, and that we're moving closer to what we'll see probably in the exam. Okay, so this will be a nice non-calculator question. Factorise this term, and it'll be a difference of 2, common factor first, and then the difference of 2 squares. Okay, it's a sort of nice process, nice flow to it. Okay, so let's look at what I mean by this. Okay, so if we've got the question factorise 10x squared minus 40. Okay, so first thing we're looking at is we want to go through a process in our mind, and we want to ask us certain questions. So we're seeing the word factorise, so we know what we're going to do, okay? Sometimes they'll put the word fully in there as well. Okay, so factorise or factorise fully or factorise completely or something along those lines. So as long as we've got that word factorise, we want to follow this process. And I want you to write out the letters C, D, and T. Okay, so we've not covered T yet, but we're looking for common factors and we're looking for difference in 2 squares. So ignore the T for a second. We're going step by step. We're looking for common factors first. Has it got any common factors? Then we're looking for difference of 2 squares. Has it got difference of 2 squares? If it's not, then we'll look at the final letter. Okay, and that will come later on. So if we've got that in front of us, we've got CDT. C, common factor. Does it have common factors? Does the number 10 and the number 40 have a common factor? Yes. Okay, you can go through them in your head very quickly, or you can look at 10. Does that go into 40? Yep. Okay, so 10 comes out. Is there any letter as a common factor? The answer is no. Okay, so nothing else comes out. We've got 10, we've got x squared, and we're minus 4. Okay, so we've got that term in front of us, but we're not finished the question yet. Okay, so we've not factorised that fully. We've factorised that by taking out a common factor. We've not factorised that fully. So we need to be able to spot that now in this bracket, we've been left with x squared and 4, a squared letter and a squared number, and they're taken away. Okay, so the difference of 2 squares. So we want to factorise fully this bracket. So we're going to leave the 10 as is. We're not going to do anything with the 10. Okay, so the 10 stays. The 10 is part of the expression, but it stays outside. Then we're just going to split that bracket into 2. Okay, putting our first term in, positive or negative, whatever way around you want to do it, okay? And then your 2 and your 2. So that is that expression factorised fully. So we've looked at CDT. Has it got common factors? Yes. Let's remove that common factor. Let's look at that bracket now. Is that bracket telling us something? Has it got a difference of 2 squares? Yes. We break up those 2 squares. Okay, so that is factorised fully. Okay. Not hanging about. Question 10 looks at that. Okay, so let's try a couple. No, I don't like that one. Try that one. Try that one. Try the. I don't know why they do the letters. Try that one. Alright, so another 4 questions. Okay. Let's take 5 minutes or 5-10 minutes doing that, and then let's take another wee 10-minute break. That's another hour. Okay, so let's come back together at 8:05. So give them a go. Okay, so I want you to start, when you see the word factorise, I want you to write out the letters CDT. I want us to tick off as we go through them. Common factor, yes. Remove that common factor, create a new bracket. Difference of 2 squares, yes, and then go through it. Okay, so it's going to be a maximum of those 2 letters in that CDT. Okay, so 8:05, come back together.